We have seen in the previous tutorial that we can use filtration in order to separate insoluble solutes from solvents. What if I have a soluble solute inside the solvent? How could I separate it? For example, if I have sugar mixed with water and they form a solution, how can I separate back again the sugar from the water? Can we use filtration again? Of course not, because the sugar dissolved in the water will all pass together through the filter paper and be collected in the flask. What can we use instead? Well, crystallization is the solution here. Crystallization is the separation technique we use to separate a soluble solute from the liquid, which is solvent here. So if I have sugar dissolved in water or salt dissolved in water, we can separate them again like that. This is the setup for crystallization, where we have an evaporating dish on top here, where we put our solution that we aim to separate inside the evaporating dish, and we put the evaporating dish on top of a beaker that is containing already a boiling water, and together the beaker along with the evaporating dish, we put them together on top of a tripod where we have a Bunsen burner turned on under the tripod. So we start to heat our mixture, and after a while the solution will start to evaporate, and you can see small crystals that will start to appear through time. And whenever we leave the mixture for more time, whenever it cools down, you can see more crystals that will start to appear. Examples of crystallization are as follows. In the first picture here, we have crystals that are found in the giant crystal cave in Mexico, where they took over 500,000 years to form. So these are some examples of crystals. Another example is the salt that we use in our food. Salts can be produced by the evaporation of seawater, by the crystallization of seawater. So after we purify the seawater, we can follow the crystallization technique where we can evaporate the water and the salt will remain inside our containers. That's how we collect the salt that we use in our food.